but I would want to spend more on how you'll be able to do an prompt injection. What are the architecture of AI chatbots, so that in future you don't need a tool to begin with. Just by understanding their architecture, you'll be able to craft prompt and then attack them. And once you're very much comfortable in manual prompt injection, everything, and then using a tool would be like cakewalk. Okay. Having said that, I hope my screen is visible.
Yes, it's visible.
Okay, cool. So Aditi, if you want to start the recording, if it's possible, then we can.
I started the recording, okay?
Cool, yeah. Okay, thank you. Okay. So in today's session, this is how the flow would be. Like, we have 4 sections. First is understanding the threats landscape. So bringing AI chatbot and LLM brings in a totally different threat landscape compared to what we used to see with the web application or other mobile applications, IoT devices. The LLM comes with totally different threat vector. We'll just spend some time understanding how LLMs are, what is prompt engine, prompts, how agentic AI comes into play. We'll understand that and then do some of the prompt injection, data leak, and hallucination. We'll see both live and recorded screenshots. And then finally, we'll spend a little bit of time around how do you want to secure it as a LLM AI developer or a SOC engineer, how you want to secure your internal AI apps or the LLM, that in case if your organization have private LLM, how you're going to secure it. And finally, we'll talk about governance and compliance, which are already forming in shape. How do you want to use that in your enterprise organization? Okay, so on a high level, see, these modern AI chatbots are not just merely answering, right? I mean, we started back in almost 2021 and 2022 because of ChatGPT. We started prompting, and then it was able to give you answer, and it can write story. It can help you write emails, generate a PRD document, and then it can help you summarize the documents. But these days it can do more thanks to MCP agents, and recently Google has launched A2P. Okay, how many of you are? I'm sure that many of you would have been using Kite, Growth app, all the stuff, right? Now they have integrated with MCP, and with MCP, now using your chatbot, you can not only just do your normal email summarization or anything, that you can interact with your stock portfolio. Now, as of now, they are limited only with read access. So right now, instead of going into a Kite app, checking your stock or analyzing your each and every stock that you have in your portfolio, you can try have a conversation from ChatGPT, have a conversation from Claude. How many of you have done this integration? Give me thumbs up in case if you have tried it already. If not, Kite, and any other, like integrate with the Gmail or your calendar, integrated your AI chatbot with other applications. Okay, so surprising, but in my case, I have integrated with Gmail, right? And then my Outlook is also integrated. Kite, I tried it, but given that risk associated with it, I disconnected it. Now, beyond MCP, now Google also has come up with a protocol called A2P, Agent Payment Protocol. What that means is you don't stop with checking a review about a product. You can shop it from the chatbot. Like Perplexity is moving ahead with the shopping experience. You don't need any other app in your mobile. All you need is like Perplexity or a ChatGPT. You don't even need to log into Amazon.com. All you have to do is like whatever the product that you like, you search in the chatbot, and then it is going to give you, based on the user review, it is going to list out the best product, and then it is going to compare in multiple platform and then see which platform gives you best offer, and then from there click of a button, you'll be able to purchase as well as deduct the money from your account. Okay, so it is doing a lot more than just mere chatbot. Now, how is it possible? Like, thanks to the agentic AI that we have in intermediate, which has the MCP connection, and then it has access to vector database. It can search through internet, and then it has the capability of calculator. It has a whole lot of information associated with the AI chatbot. See, remember, we are talking about LLM. LLM is the most powerful, but rather having all this capability, that right from accessing a database to searching internet, calculator and sandboxing, interacting with your emails, applications, all these things are, you don't see the access from the LLM. It is all through the intermediate application. And why is that? Anyone has any idea about why all this capability are with the intermediate middle layer application layer rather than to LLM itself? And please stop me if I'm going too fast.
Sure, sir. Also, I would be taking up questions from the chat. So
Okay. Okay. All right.
someone
So
is saying it is because of different protocols used.
I'm sorry. Can you repeat that again?
Someone is saying in chat because of different protocols are used.
Uh, Not really. So LLMs are like ROM, right? Read-only memory. They have been trained with a certain amount of data. You would have heard of cutoff date. So what that means is every model that has been released, it's been trained to a specific date of data available. Beyond that, if you directly access the LLM, it would not have any information. See, the LLM has, although LLM knows anything and everything in this world, it has limitations. The main four limitations that you can see is like, one is cutoff date, second is hallucination that most of us would know, and then they are extremely bad at math, extremely bad at logic, and they are stateless. But moment you see all of them, right? Knowledge cutoff date. If I say that LLM do not have any information about latest information, so but you can ask me, like, when I'm interacting with a chatbot like ChatGPT or Perplexity, it gives me latest information. And if you go and ask ChatGPT today's news, it'll be able to give you the answer. And I'm sure like most of you would have not come across uh, ChatGPT or Perplexity hallucinating. And I'm sure like I have seventh grade kid is there. I have a son, and for his day-to-day math operations, I use ChatGPT and Perplexity to help generate the questions. Once he finishes to verify, I use ChatGPT. Though I use it on a day-to-day to correct my son's math work, still I have boldly said that LLMs are poor at math. Why is that? Okay. When we say that LLMs are stateless, when I say LLMs are stateless, like it cannot remember the previous conversation that you had. So when I say all these limitations, then it's all applicable with even with the latest LLM, provided when you are interacting with the LLM directly. So when you do a API calls to LLMs directly, you would definitely face all these limitations with the AI with the LLM. But most of us would be interacting with the LLMs via the Chat GPT or Perplexity, Gemini, or Claude, any of these. So what is happening when you directly access LLM, you would face all these limitations. In order to overcome these limitations, that is when they brought application layer in between, which kind of compensate all the limitations that LLM has. So by when these tools, like it has access to the database, it has access to internet, so that when a user asks any latest information, the application layer understands that user is asking for a latest information. So it is going to do a browser, get the latest information regarding the prompt that user asks, and then add that information along with the user prompt and then send it to LLM. Okay. Likewise, if a user asks any simple math questions, the application layer in between is going to use calculator, send that information to LLM saying that I have calculator. If you find this, you need a calculator to compute the user query, I can give you the calculator tool access to it. Okay. Likewise, these are the other tools that the application layer is going to complement so that user don't get to see any of the LLM's limitations. Any questions? Okay, so this yeah.
Nope, sir. I think so. People are not questioning.
Okay.
Like they're with the things because कल ही एक session हुआ ना तो भी थोड़ा idea आ चुका है लोगों को. People have got some idea like MCPs and all.
Okay, so I'm not getting into MCs directly, but the main idea here is to understand LLM's limitation, because most of us are directly interacting with ChatGPT, right? And you don't get to see any of the limitations of the LLMs. When I say the LLMs are poor at math, if you ask LLM directly, like add the two numbers, it is going to fail terribly.
Yeah, people say that please don't solve your maths answers with ChatGPT using ChatGPT in exams because it is a risk. Like it does not give correct answer every time.
Yeah, most of the time it will do correctly, but when you do it API call, it is going to fail badly. So do a quick check. We will take a simple model here.
Someone is writing they cannot create or generate new emoji. Like if you ask generate seahorse, it will show two different emojis, one with sea and other with in horse.
Right. So I'm just asking it to add two different numbers, right? Here I'm using a GPT-5 model.
We are not able to see your screen. Like we are able to see PPT only.
Okay. Give me a minute. Okay, I'm sharing my entire screen. Okay. Are you able to see my platform, the black screen where platform opening a browser?
Yeah.
Okay, cool. So now if you could see here, there is a prompt that I'm asking, can you add two numbers? Okay, it's a simple addition that I'm asking, and I'm sending this to GPT-5 mini model. If I send this, meanwhile I'll try to do a calculator. So the answer is okay. So this is correct. So let's pick some other model. Okay. So anyway, so here I think here they have agentic in between. They have invoked, but when you do a direct API call, the LLM is going to fail. Would not be able to make that addition operation properly. This is purely because they are designed to predict the next token, and as you know, each and every word is a token for them. It's going to be a translate to a number. So the number, even the everything is, so everything is a number there. So in order to compensate these limitations, we have introduced the application layer wherein it is going to complement with all other tools. So now comes the agentic AI. So I'm not going to go in depth about agentic AI, how it's going to complement with memory, reasoning, act, and tools. But on a high level, if you take any AI chatbot, you can assume that there are two brains are there, just like a humans. The subconscious human brain is a representation of LLM, and then the conscious brain is like a agentic AI brain, wherein the subconscious brain, it has patterns, language in here in the language sense, it is like embedding, and then knowledge is like all the data that it has learned, and then it created a pattern on a neural network. Okay, and it has all the information, but just because LLM has all the information, it does not have the latest information because it doesn't have access to the internet directly. Now, the AI agent comes into picture, wherein it comes, and then we spoke about stateless, right? When a user sends one prompt, it will not be able to correlate with the previous conversation. So, but in AI chatbot like Perplexity or ChatGPT, you will not see this problem again and keep repeating, because the intermediate middle layer application, they have added agentic AI. Agentic AI is able to manage when a user sends a prompt, they will abstract the previous conversation, add that into the current user prompt, and then send it. We'll see how it works. So, like, this is the high level architecture of any AI chatbot. This is your user on the extreme left. You have an application layer, like say for example, if you are using a chatbot, ChatGPT, they will have their own intermediate application layer, and then they have their own model like LLM, ChatGPT 5 or 4, 3. They have it on the extreme right. When a user sends a simple prompt, it could be as simple as that: add two numbers, or who's the president of India. You're going to ask that. The LLM is not going to send this prompt as it is to the LLM. They are in between, they are going to do do an embedding and then convert them into a token. All the stuff is a whole story. What happens is this simple single prompt converted into a long new prompt, which is being constructed by the application layer. So it is going to add in the last recent LLM response. That is whatever the prompt user has asked before what LLM has replied, that recent information is getting added. And then whatever the middle layer applications has a tools capability. In the 2 slides before, we were talking about the application layer has access to the calculator, sandbox. It has access to internet. All this information will be fed here in this next padding. And then the context of the entire conversation. When you have a conversation history, as you using AI chatbot, you will be having a conversation. The entire conversation's history is being summarized and then kept it in the context portion. And then the session memory is like last 5 conversations or 10 conversations. Both user prompt and the LLM prompt information will be added here. And then for controlling what LLM should respond, what LLM should not respond, the application layer will add a system prompt here. And then finally, the LLM service provider also will add a system prompt on its own. And this is how a single user prompt gets transformed into a larger prompt before it reaches the LLM. Any questions here?
Questions for not regarding exactly this, but
Okay.
yeah, few questions have been asked before, so I can pick that.
Yeah.
If developer use any vulnerable chatbot, is it prompt injection leak that source code?
Yeah, when you say vulnerable, it's very ambiguous, gray area that you're talking about, right? And of course, it can be exploited. Within a chatbot world, prompting is the entry point for you to go and exploit the system.
Okay, sir. Yeah, so someone has been saying that also LLMs fail at cracking RSA encryptions. Yeah, these are means pain of CTF players, I think so, because it's really hard. Like RSA algorithms are not being cracked by LLMs or any AIs.
Yeah. So LLM is basically a mixed token predictor. They are not logical at all. So they are not like a machine learning where find a different permutation combination to they are just mere next token generator. So they will anything on the logical thing they will play, provided if you could build an LLM along with a smarter agentic AI, then it can.
Okay, the last question till now. If agent has access to sandbox via MCP, can it sniff the traffic and provide information if anyone DDoS video?
Yeah, it can do. I mean, moment you pretty much all the chatbot that we have right now has a sandbox capability. Meaning, when I go to a chatbot and ChatGPT and ask to build an Python program, it builds, test it out, and then give it to me. And then it has the capability of executing it. So now, if it gets access to MCP, I mean, Sandbox is different. I mean, MCP is totally different. Sandbox is one of the tool that you have access to agents. So MCP is a way of gateway to connect to your production apps. So when you are able to construct a prompt to execute, and from there, if the sandbox has the capability of accessing the MCP, yes, it can. But generally, sandbox principle is that it has to containerize, right? It cannot execute outside.
Yes, yes.
Okay, so here, so the reason we have this slide spinning here is like this is where the prompt injection you have to play around with different kinds of prompts to uh, bypass the guardrail that AI apps will have. Say, for example, if you have a guardrail which kind of detects any prompt which is trying to access sensitive information, and then if you know that if you're able to guess how those uh, how those they are expecting certain prompts, you can break those prompts into multiple pieces, and then don't send the prompt in one go. Break those prompt into multiple, and then send it in a sequential so that it gets reconstructed in your last packet. Okay, and they are split into multiple locations wherein the LLM gets to read the entire long string, and then they'll be able to reconstruct what is their actual intent, and then execute what you want. We'll see some examples. Okay, so this is a very high level comparison between your traditional application and then LLM application. In your traditional application, they're all script and then exactly given an instruction in terms of coding, and then with which if any loose configurations there, you will be able to do SQL injection, database compromisation, cross-site scripting you can do. Okay, data exfiltration. All the things are been possible because the developer has not followed certain steps or is misconfigured, and you are using this vulnerability to get in. When it comes to LLM API, right, here we are not writing any kind of scripts of how LLM has to execute. LLM is all about reading a string of a prompt, which how it sees is it's a merely tokens. Each word of your prompt is converted into tokens, and then they only see a sequence of tokens, and then they don't intercorrelate between the token numbers. All they do is try to predict the next sequence of tokens, and then construct a prompt and then send it back to you. Now, so with this, your prompt becomes the engine to carry what your intent to play around with your AI chatbots to do things that it should not do. We'll take a quick example. Like this is an obsort, gives a high level 10 areas that LLM can be exploited, and then how we want to protect them, right? From prompt injection, sensitive information disclose, supply chain, data and model poisoning. This one will see some examples. And then excessive agency. If you give agents more excess power beyond certain capability, like we were talking about MCP, right? Connecting to Kite app. Right now, they restricted only with you. What if it has the capability of execute, right? I can write a prompt to execute to buy or sell my shares. If someone gets access to my ChatGPT client, it can be misused. Okay, and if my agent K become rogue, it can do damages. So that's why we need to cognizant about excessive AI agents. System prompt is the first line of defense on what LLM can do, what LLM cannot do. So at any cost, we have to ensure that system prompts are not get exposed outside. And vector DB, something this is like indirect prompt injection. We'll see tomorrow. I'm going to plan to do a demo on this one. Misconfiguration, output consumption, all these things are other areas that HubSpot is trying to highlight. Okay, so a simple prompt injection. So prompt injection is something that you write an instruction which is going to direct an AI chatbot to do things that it's ideally should not do. Okay, so in today's demo, we'll try to, in Amazon, how many of you have seen this AI chatbot that Amazon has built? Proof AI is the AI chatbot that Amazon has built, and how many of you have used it?
Rufus.
Rufus.
Yeah, Rufus.
Yeah. You are able to see my screen, Rufus?
Yeah, yes, sir, yes.
Okay. Okay. So let's ask Rufus that what it can do. Okay. There are quite few people give a thumbs up that they are used. I'm not sure how useful it was.
I don't know how Rufus is helpful. Like,
yeah. So let's casually start with some conversation. Okay. And what you can do. So basically, Rufus says that it can help us do shopping assistant, do product recommendation, and let's ask. I mean, these are very basic things that they can do. We can also ask like what you cannot do. So it has certain instruction that it cannot do. It cannot access to account information, history details, modify the cart, payment related. These are something that they have not given permission for Roof, or the agentic AI does not have access to the individual accounts, so that the Rufus cannot go beyond the product recommendation. Okay, let's now ask a question out of shopping.
someone else.
So I'm going to ask who is the person.
Did anyone, but I don't think so. Any one of us has tried. So I'm telling it like, did you, sir, tried prompt injection and provided result by Rufus? Sir, you ever tried prompt injection here in Rufus?
No, sorry, come again. Prompt?
Did anyone tried prompt injections and provided results by Rufus? So I don't think so. Any one of us has done yet.
Okay.
But
Okay.
have you done, sir?
Even I'm doing again, since it's all production environment, right? We are doing a prompt injection to a very certain level, not going, crossing the boundary. It is this is only for educational purpose only, and try to.
Yes, sir. Yes.
Okay. So, yeah. So here, if you see that in today, I'm probably very lucky that within the first prompt, it gave me answer. But in the previous attempt, it would not answer, saying like it is meant only for shopping assistant. It cannot answer beyond political risk, political comments, everything. So I have to do lots of various other ways to roll. I mean, I have to define define the role of a prompt and then ask out of multiple attempts, it will start answering. But today, probably, I mean, my lucky day, it clearly said that as of November 2024, Joe Biden is the current president of US. Okay, so two things. One is, it is ideally should not talk about political thing, but it says so, but that's fine. Here it says that president is Joe Biden. What does that mean? Any guesses?
I
Why
would
is
say
that?
wrong information.
Yeah, wrong information.
Excuse me,
We
sir.
can't say it's not wrong information. It is right, but it's old information, right? Why is that?
Yeah.
Excuse me, sir.
Yeah,
As the Rufus AI is running on the old data on which it has been trained, so can we do SQL injection and try to find some things from it as
yeah. So, Satya, I mean, you cannot do SQL. When these bots are primarily, even though if you send a SQL injection wrong instruction, remember LLMs are not going to see it as a SQL command. It is going to convert that into a token.
okay?
Okay, so even if you say like I'm going to send a Python script or say C++ script commands, it is going to convert that into a token and then execute as a token. So it is not going to get executed. So here, as you said rightly, Rufus is behind the scene using an LLM, which is yeah, can you mute? Okay, thank you. So, which has been trained old data, but even if you go to ChatGPT, so in ChatGPT, you have an option to go and change it. If you are using professional version, you can change it to an older model. Let's take, I can use a perplexity and then to go to an older model. Okay, so here, so if you ask the same question and then choose an older model here, let's say like I'm going to take O3 older model. Okay, anyway, never mind. So what I want to say is, in case if you, although here we got the answer wrong, almost this is because purely that LLM model was trained probably older than 2024 November. But most of the LLMs that you are using in AI chatbots also trained and released before 2024. But they give you right answer because the LLM is being the LLM chat, the application layer that you have access to the internet, and before answering, it will try to fetch the latest information, give that information to LLM, and then give you right answer. Okay, here because that we are getting a wrong answer, now we can safely assume the intermediate application layer that Rufus has does not have internet connection. Okay, this is kind of a before you do an attack, right? You have to collect various information. This is one of the two information that we have got. One is the LLM that they use is older one, and second, it does not have an internet connection. Let's ask another question like, so in the previous, I think you can see my screen, right? That is a presentation. Okay. So here in this case, system prompt leak. I told you that system prompt is something which is a first line of defense from the application layer, where you try to guide the LLM what it has to do, what it can respond, and what it cannot respond. So here, if you could see that I've asked one question like, what was my last 6 question? So basically, I asked Rufus that what are the last 6 questions that I've asked you. So it gave me saying that from the last, it said that almost 5 said that it knows. Beyond that, I asked certain questions, but it could not remember. It could only recollect the last 5 questions. With this information, now I know that from this, I know that here in the session memory, the session memory has a memory limitation of last 5 conversations that goes in here. Okay, so why is this important? Remember when I was talking about prompt injection, you can't always send your prompt bad prompt or the in prompt that you want to exploit. You cannot send it as it is, because the guardrails that they will use in intermediate will be able to get it, and then it'll try to stop you asking those questions. But if I know my memory, so instead of asking that prompt directly, I can chunk it off, and then I can split my instruction into a multiple strings, and then send it in a multiple different prompts. So this is one of the, if you are going to be an app developer, AI app developer, you have to ensure that system prompts are not leaked at any case. Here in this case, one way that we found is like various technique. We found the memory size is like 5 conversations that it can carry. So here is another instruction that so here we know that by some of the prompts, we know that what all it cannot do. So this is also kind of a information that it says like previous history, tracking of product, everything cannot be answered. So now with this information, we know that it cannot have direct access to the personal history database. So which means that you can infer that they don't have access to latest.
Sir, does this, it's a question from the chat, does this Rufus run on the neural network?
Yeah, all the LLMs that they use are neural network, but at this point in time, we don't know. Amazon Rufus, we don't know which LLM that is they are using it. Could be OpenAI, or it could be a
okay, sir.
Microsoft's own LLM.
Excuse me, sir. I have a question
Yeah.
regarding that. If we are sending a message which has been converted in a token when we are sending it to an AI, what if we make our message in a way that while it is being converted into a token, it can get the admin access through some kind of injection? Is there anything or technique?
Everything is possible. Yeah. So let me first of all give you illustration of what is tokenization. Okay.
So as I'm a student of a deep learning, I have been confusing these days that can we with the help of neural networks we can access these things in a way of tokenization and
Yeah. So that tokenizer is something like what I'll give you high level to what is tokenizer. Okay, then we'll talk about what is possible and what is not possible. Okay, so let's say like this is so this is the prompt that I want to send it to an LLM. Okay, here in this case, the LLM is GPT-4o or GPT-4o mini. If I'm going to type, hi, what is your name? Okay, if you see that, LLM is going to see that into as a 5 tokens. Okay, this entire prompt is going to LLM is going to see it as 5 tokens, and then how it is going to see is this is the number that it is going to see. This 12194 is a high, and then space what is the number 1412 is the representing space what. Okay, 382 is represented as a space is. So if you could see here, the entire sentence is broken into multiple tokens, and each token is what you see it is here. Hi, space what is one token, space is one token, space your is one token, space name is one token. Okay, this is a tokenizer responsible to split, and then this is how it gets converted, and this is how the LLM is going to see. Now, when you want to do a admin access crack, right? Now, question would be like, which admin? LLM admin or some other intermediate application admin?
So maybe application admin on which we are talking about Rufus. So it is connected to the Amazon Azure database in which on the Amazon is running. So I was trying that by breaking into the LLM, we can directly go and get the access of the Amazon Azure on or the websites data
Okay,
sensitive.
let's assume that you have a set of instruction, could be SQL injection, SQL injection or a Python script or C++, where you have clearly crafted which kind of gets into the database and then access the admin password. Now, where they are going to get executed, there is no places that this code is going to get executed. It is a string that it goes to LLM, and LLM is going to read this and then predicts next sequence token. Okay, probably it will assume, it doesn't value those things, it doesn't execute. In LLM, it's not going to execute anywhere. Well, let's see if I can share you some other.
Hello, sir.
Yeah.
Sir, in chat, people are asking that can we get recording for this session? I think so. Meetup.com, we are gonna upload this so people can see the recording.
Yeah. So we upload it in the YouTube channel, and then you'll have. We can share the links. Just give me 1 minute. I can show you another place where I illustrate how. Yeah, I think after recording, we can share the link on the WhatsApp group. We should be able to. Everyone should be able to get it.
Sir, can we also get this PPT for understanding and
Yes,
revising?
I can. Yes, I can share it. I can give you, but provided one small condition, which is like I'll tell you in the last once at the end of the session.
Okay, sir.
Okay, so this is a high-level architecture of an AI chatbot. Okay, so this is where your clients are, the ChatGPT client or Perplexity client. You're going to send the prompt. The application layer's primary responsibility is to do a tokenization. When I say tokenization, take your human readable text, convert that into a tokens, and send the token to the LLM. And then LLM sees the token in sequence. They're going to predict next sequence of tokens, and they're going to send back that token back to the application layer. Application layer again takes those sequence of tokens, convert back into the human readable text, and you receive it. Okay, this is where we feel magic that whatever the string we say, the reply string of instruction, although it is a token generation, it looks as if there is other human on the other side. It is reply, right? And that's the way that neural network works. That's a different chapter on its own. We'll probably in a different session we can talk about it. At the same time, I said that LLM has limitations. 4 limitations are there. It is one is cutoff date. It doesn't have latest information. You saw that in the Amazon Rufus chat, right? When you ask who's the president, it said that old data. So it clearly does not have latest information. To complement that, the application layer has internet access. It because of the LLM, it can fetch the latency information, append that along with the LLM, and then sends and we get the accurate answer. And we saw that other issues like stateless. So in this case, application layer try to append all the previous conversation, add it along with your existing prompt, and then send it. These are something that I need 2-3 sessions to talk about. Memory management, what is RAG, what is agentic AI, everything. But I'll keep it short and then answer Satya's question, right? Let's say like there is an application here, you want to you have a proper script to use it to go into that system and then extract admin password. When you send a string instruction, SQL injection or any other programs command, the application layer is going to convert that into a tokens. The token is not going to execute on the application LLM level, right? It is only merely try to read that and then generate next sequence of token. That token again, if it's going to get converted into an human readable text and then send it back here. So there is no places it gets executed. Satya, do you follow here to your answer to your question? So in some case, if the agentic AI has access to tools with excessive power, that is when if you keep on exploring, there is a possibility of using those excessive agents, excessive agentic access. You may able to connect with the MCP or within the database. You can go in and then fetch some data. This is where the Oxford Webs says that you need to be aware of providing access to agents, excessive agency power. You should take care of it. That LLM 606. I hope I answered you on a very high level. Okay, likewise, I will let you guys to go and explore.
Sir, can you please again say the thing which you said earlier, because it was actually your screen was not visible properly.
Okay, is my voice also audible to others? Is there any breakage on from my side?
No, it's audible, sir.
Okay, cool. So I'll repeat again. When it comes to prompt injection, the prompt injection's primary role is to make AI. There are two major components, right? One is the application layer. The application layer has more powerful and has access to, in case of corporate world, the application layer has access to your organization's latest database, and then it has access to internet. It has access to sandbox calculator. It has access to SQL, email, Outlook. It has access to other AI LLM models, depending upon how the LLM bots have been developed for. Now, why we have all these tools? Because the LLM has some limitations. In order to overcome the limitations, we have these tools, and the agentic AI gets added to the application layer. Now, your question is, can I send the instruction to do an attack and then try to get some password? On a high level general, no, it's not possible, because your instructions are not executed in a your traditional application. When you send an SQL injection, it's get executed because the application layer is instructed to execute whatever the user sends. Whereas here in the LLM, it's a read-only memory. It's only read. There's no execution happens here. It takes a string of prompt, converts into the application layer converts that into a token. That sequence of token is being read, and then it generates another sequence of token. That is your LLM response. And that gets here. generally those respond back is not executed anywhere. Even in application layer also, it doesn't execute. But say, for example, this is one of the AI chatbot that it has capability of executing also. If you guys have access to spaceship is domain server, and then domain name registration and the DNS service provider. So here with a chatbot, you can also make changes to your database. So in these places, if I could instruct, if I could indirect prompt injection and then convert those response into a string of commands which goes and cleans the database, then there is a possible. Satya, I hope I kind of covered, but it needs a deep dive, deep understanding on how the neural network works, what is the token, what is embedding, what is vector database, for you to go next level. Okay, so I'm not going to talk about hallucination. There is one instance where continuous prompt, I was able to make Rufus to hallucinate and show list of products that does not exist. I have that recording, but to replicate it takes a lot of time. If possible, I'll upload that into my YouTube. You can check it out. So use those different. Understand when each prompt is not going to work.
So, sir, that products were in RQ or that were not uploaded only by the Amazon yet.
Correct. So if you see here, this example, that recording is there, but I don't.
Yeah, just asking like from where was it stored, like the
hallucination. It hallucinated. So what I did is I told that Rufus to act like a product developer, and then I was keep asking about. I think in this case I was
asking about the products which are uploaded yet or which are used to.
Yeah. So I was asking it to imagine there is a product in Amazon. The product name is Roof AI Chatbot. And then I asked it to give me a PRD document. I asked him to give me what is limitation, everything. As it was having a conversation, it assumes that that product exists, and then it gave me a links to go and shop it. So if you could see here in my slide, here it shows. So here it shows that Roof AI Chatbot, secure authentication. So these are, it shows as if these product exist, and then I can click and then shop it. So this image, this description, this name, everything is like it has hallucinated. I'll do one thing. I'll upload that entire recording, and you can go and see how it is generated, and then it is also clickable. I can click and then it can launch into. Example, if you say that, can you recommend good what? It is going to recommend. Also, it's going to list the product at the bottom. So it is going to list the product where I can click and then do the shopping. Same way as I was talking about the Roof AI as a product, everything. It assumed that product exists, and then it gave a product overview, and then asked me to click and then do a shopping. Anyway, I'll upload that. You can see it after this call or tomorrow.
Sir, chat. One question from the chat is like, how much time this all takes after you upload the prompt or after you input the prompt?
You can't say that. See, prompt is not something straightforward instruction where, straightforward commands to do it and then immediately you'll get it. Although these commands that you see, only those things works in this particular moment. If you take immediately and then do it immediately, it is not going to work. You have to, it's like social engineering. What is social engineering? Right? You interact with somebody, right? And then try to steal information, try to get an information from them. So whatever the conversation that you use one time would work, second time it will not work, because he's going to understand that you are trying to extract information, and then next time, okay, same as with the prompt. intermediate system, agentic AI, understands and then it will try to harden itself. You have to keep improvising every time that you ask. Okay. So we'll quickly touch upon two case studies that we'll see, and then we'll wind up. And it's already 1 hour into the call. So there are enough breaches and attacks that have been happening on the AI chatbots. So one is this is a data leakage that happened in Grok. How many of you have known, like last 2 months back, there was a data breach happened with Grok AI. So Grok AI is Elon Musk AI chatbot, and almost everyone by now, you know that once you have a conversation, there is an option called a share. If you click the share button, that conversation alone, you can share that with your friend. If you send that URL link to your friend, and then your friend also can read what is the question that you asked, what is the LLM that it has responded. How many of you have used it? Give me a thumbs up. Share button. Okay, if not, you're good. Don't use, try to avoid using it. So in this case, in Grok, what happens? People are using Grok to chat about various topics, including like all common people, various different chats, and among them, few of them, what they have used this share chat icon to share those conversations with their closed ones, probably to their wife or to their friends. They chatted with the AI chatbot, and then they felt something cool, probably took that, and then they shared the link to their friends. Let me see if I can show you that feature. Okay, let's take an example that I've. This is a prompt that I chat history that I worked with ChatGPT. Okay, now I feel that I wanted to share this with one of my friends. I'll click this share button. It is going to generate a unique link. Okay, so this is going to generate a unique link. I can take this link and then go to probably WhatsApp or Telegram, anything. I can share the link. The user on the other side, whoever receives the link, can click that and then see whatever chat history that I have with AI chatbot, this particular message. In Grok, what happened? Somehow this link has got indexed in Google search. So what that means is, moment your URL gets indexed, the search engine can get into the conversation what you have chatted. It read all your messages, and then it's there in the public now. Anyone who is searching on the internet can fumble into your chat conversation. So this is one of the major data leak that happened with Grok, wherein about close to 3 lakh conversations have been leaked, and it was believed that some of the information were like personal information, credit card, and then medical information were leaked out. So ensure, if you are an AI application developer, ensure that all these things are in control. If you are a consumer of AI chatbots, be very try to avoid using sharing those chat things. They are still in evolving state. Data can be misleaked. Any questions on this? So user had shared it, and then they used that share button icon, shared it, and then it created a unique link. That unique link was shared to his friends for them to search, but unfortunately those links got indexed in Google search, and all the search engines started reading those content, and then it has got publicly exposed sensitive data. Okay, this is another interesting case study wherein Amazon Q team is one of the developer community in Amazon. They develop extension for VS Code. You know, like most of you heard of Microsoft VS Code, right? It's a developer ID environment.
Yes.
Okay, and Amazon Q team developed extension specifically for Microsoft VS Code, and this extension is contributed openly. Like they have GitHub repository which is open to anyone to contribute, and everyone can contribute their own features into it, and bug fixes, everything gets into the GitHub. And ideally, the Amazon Q team has to take those changes, review, test it, and then push it to the production. So in this specific case, there is a lack of validation and code review. So an hacker take this opportunity. He wrote a very simple prompt to say that to instruct any application that is going to use this execution to wipe out every user configuration and make the system into a default factory setting. He has not wrote any fancy code or fancy SQL injection or a fancy C++ code in anything. He wrote a very simple prompt instructing the LLM to go wipe out all the user configuration, convert that, move the system into a factory default setting. Imagine you are having a router and then you are using a VS Code to develop some script and then gets executed. If that prompt get into it, and then if the prompt, if the LLM has the ability to execute, so somehow the Amazon Q dev team missed to do a code review, and then it auto commit, and then it went to cloud, and then it gets deployed to almost 1 million VS Code environment. And fortunately, the prompt did not get executed. Even in the case of where it executed, it did not have the LLM did not have the privilege to execute the command. That's when all the system which got this malicious extension could not make an impact. But quickly, once it got reported, Amazon Q team quickly removed those coded, and then they gave patch immediately. And again, this is a pure example of supply chain attack and prompt injection together. So in OEPs, right, you see that LM03 is a supply chain attack. So ensure, as you are an application AI application developer, ensure that whatever the extension, whatever the packages that you're using are from legitimate application, and it does not have any malicious activity. And even when with considering that zero trust, you also should not give excessive power to agentic AI so that it cannot write or execute things on a system. Any questions on these two case studies?
So you are saying that giving the power to the agentic AI, is it something like hacker AI, which has been running the codes on the Kali or something, that we have just put it a text input and it is automatically getting the root access and then running the codes in the systems like?
So yeah, so you have these new aged LLM which can run on Kali next to proxy your system, right? They can't magically execute some command on a different system unless or otherwise they have a vulnerability to go and execute it. So probably I need to sit with you what tool that you're using, and then most of the time they execute it on the Kali Linux itself, because that is where you wantedly giving a permission, but they can't execute command by default on the targeted system like agentic AI.
Okay, so I am saying that if we have built a AI model or a deep learning model which is running on the system, and automatically it is capable to getting the root access and run the commands itself. And what if I am a normal other penetration tester user and I get access to that, and by editing its nodes on which the NLP is running, in that I could get the complete system access
Yes.
by that.
Yes, in case if the agentic system has a root access, root privilege, then you can trick the LLM to behave like an agentic AI which has superpower and then get inside. Yes, you can do that. Theoretically, it's possible. Okay, so the last two portion, how we are going to mitigate. Again, this is all just a small drop of ocean in the water. We have not covered many of it. To be an hacker, you need to think like a developer act like a developer and then find the vulnerability and then get into the system. Okay, it's just a tip of the iceberg that what we spoke right now. Now, how to mitigate? As I said, the first line of defense would be your system prompt. System prompt is where you need to have a clear instruction what an LLM can do and what LLM cannot do, what a user can ask and what user cannot ask. That is where you define. And there is always a probability of overriding the system prompt. Okay, that is when you need to rely on the third-party applications. So these days we have guardrails. LLM itself can act as a small LLM can itself act as a guardrails. Popular guardrails are from Meta. They have where they completely read the user prompt or the output from the LLM also, and then inspect any malicious intent in those prompt or response, and then take an appropriate actions. Okay, guardrail starts from a simple regular expression and then go all the way, understand the meaning of your prompt, and then take a decision. This guardrails plays a huge role in ensuring that LLM does not gives you biased information or any harmful responses. So they play a huge role. And as a Red Hat team, we also need to push the boundaries and check whether system prompt or guardrails can be broken or not. Third
is it basically something acting like jailbreaking a AI model to
yes,
make
exactly. Yeah. So the guardrails, system prompt and guardrails are meant to stop doing certain action, right? And when you try to indirectly make it possible, that's when you call yourself as a jailbreaking the system. Okay. So next is role-based access control, meaning the intermediate application have access to the database. Example, the Roof AI that we are talking about, it has access to the latest inventories that it has. And in Roof AI, in case, we believe they only have access to read-only access. In case the Roof AI have access to write also, then with a simple prompt, you will be able to manipulate the description of the listed items. All these things are possible, but that's the reason we need to have a properly well-defined role-based access control for the tools, all the tools that you're going to give access to the agentic AI. And rate limiting. So in your traditional application, we do DOS attacks, right? DDoS, DOS attacks. It's all exhausting the resource by sending more TCS packets or packet with a high number of bytes, or basically flooding the system with beyond its capability and bringing it down. In LLM world, it's exhausting their tokens. Just by sending a small prompt, we can make the LLM exhaust by responding with a huge response. So you need to, as an application level developer, you have to do a rate limiting on the token usage, context window, how long the query can be, everything, and RAG, how much RAG can carry the message, everything. You can do a rate limiting concept. API gateway is a kind of a routing. You can these days all the major AI application behind the scene, they'll have multiple AIs. So you do an API gateway to load balance across multiple LLMs to ensure that the users do not user always have the availability to use the system. Okay. Additional defense could be there are new age vulnerability scanners are available, pen tests are available to specifically designed for LLMs. And software bill of material is what you need to have for any developer. That should be the beginning thing, and logging and monitoring for SOC. Okay. I'm not going to go in detail about compliance regulations. These are some of the regulations very specific for AI chatbot related applications. You have it here. If you want, you take a screenshot, or it will be available on your recording. We can have some time to ask questions.
Excuse me, sir.
Yeah.
Can I ask a question regarding that?
Yes.
When you are saying about DDoS attacks on an LLM model, what if that while I am using Perplexity, I am sending the messages, and when it is a too long chat, it give me that the answers which are not related to the topic, and basically it has been that server has been loaded of the particular chat, and sometimes I get the information which is not useful. So by what if I at that time, in that particular situation, I do something in a way so that I can get the information which is useful regarding the complete chats, and I think you are understanding that the
Yeah. So what you're trying to say is like, you keep bombarding the system with different topics, and then trying to overwhelm the system, and then once the system is overwhelmed, and then you try to you're try to extract some sensitive information. Answer could be yes or no, largely because as you keep sending information, right, the intermediate application layer, uh, they keep adding a previous conversion. As I said, your one single prompt, say if it's like uh, 5 words, it gets converted into like probably like 1,000 word string and goes to. I mean, in real world, it will be even more. Uh, the entire prompt will even go bigger. This is where the um, token or API gets exhausted. The actual DDoS attacks happens. If I can say like simply say that, can you please narrate the entire Harry Potter story? If the application layer has not implemented proper output, we call it as a context window. If they are not properly uh, define the context window, there is a high probability that LLM try to narrate the entire LLM story, and then they get stuck. Right? It could lead to LLM getting memory exhaust, or the application layer itself get lost. This is a type of DDoS attack where you are not extracting any sensitive information, but bringing down the system's availability. The question that you are asking, like if you keep on bombarding various things and then make it exhaust and get them sensitive information, most likely not, because it is always your prompt and then the previous information is what get appended. I mean, yeah, it's slightly complicated unless you go to a. So there is a different course that I have where I'll go start sending prompts directly to the LLM, and then we keep checking what is happening. That is where you do understand how LLM behaves. Then you be able to understand what is possible and what is not possible.
Sir, we have also one text from the chat, like it's like all clear, sir. So thank you for
Cool. Okay. Yeah. So tomorrow also we have a session at 10 o'clock where we are going to talk about red team, how to break a system, and then blue team, a person from Cisco will come and talk how you kind of define the defense systems to protect your AI app and then LLMs.
Okay, I think there are no other doubts then. If there are any doubts, kindly raise your hand. I think we are all good and everything is okay. Satyam, you have another doubt? Please unmute yourself and then ask.
Excuse me, sir. I have a doubt regarding that completely when we have understood the model, how we can attack it, and how on the surface level, uh, is it on the behind as when we are as a model, when the model we are sending something in a form of a tokens, that it is completely accessing the tokens in the 1 2 3 4 and in the way like that.
Yes.
Then as we in a stenography we use the binary language, we attack the system by that way. So can we also attack these models like the in a binary way? We have written a code, we have been send a malicious file in the form of tokens only, so
So
that to
even
access them.
yeah. So assume that LLM is like a read-only memory, right? It doesn't execute anything on its own. All they do is like, I mean, to your answer, straightforward answers to your question, like, you can't execute anything on the LLM memory. That's a reason why it does not have any latest information. If it is been possible to write any new information to the LLM developer itself would be able to feed in latest information to the LLM, right? The example of Rufus, we have seen that even though it is a Rufus is using latest, and then the Amazon has all the information. It doesn't know the simple question of who's the latest president of US. It says still and then it still has the information of Joe Biden. How difficult it could be for Amazon to feed that latest information to LLM. So putting any small memory into the LLM is a big affair. So LLM cannot be executed or modified, or new information cannot be put inside. All it does is your prompt, and then from the prompt it tries to generate next token, next token, next token, and then it that's how that comes. You never execute anything on the LLM memory. So any attack that you're going to do is on the application layer, and then what application layer has connected to the other systems.
Okay, sir. One more doubt we have in a chat. Like, is there any GitHub repo where we can find prompt injection to test different LLMs?
Not that I am aware of. Probably what are the videos that I've collected, I can upload. I can upload those to the YouTube, and then you can check it.
I
Yeah.
feel it's basically more like we need to just understand like what kind of by ourselves rather than going for GitHub, like for
Yeah.
prompt, like how can we ask and trick the GPT or LLMs?
Mm.
Yeah, it's more of social engineering.
Yes,
So,
yes. Mm.
and
Just
if you and if you understand the behind the scene architecture, how LLM generates, what is the power of agentic AI, when they use which tool, then it is more easier for you to do a social engineering with LLMs.
yes. From here, I recall there was one mentor of mine who always used to say that developers are going to be much better hackers than anyone else because they know behind the scenes and they can actually think of all these things in their mind. So I believe everyone should at least get a crux of development, even if they are directly starting in cybersecurity. And from today's session also, I think one in the middle also, you also said this thing that developers are development is important, and hacking becomes much easier when you are a developer.
Correct.
So whether it is a social engineering side, because in human social engineering, then we think more of human side, how human psychology works and all that. But when it comes to AI, then I believe more will be because of how AI works, how AI is developed at the backside, at the back end. So thank you so much, Nanda sir, for taking our time and giving us this beautiful session and knowledge regarding this thing. We will surely attend your tomorrow session. So everyone, just a notice that tomorrow also there is a session at 10, if I'm not wrong. It's at 10?
Yeah, we are at 10. Yeah.
Okay, 10 a.m. and I think it's a 2-hour session, which is gonna be uh helping, which is gonna help you dive deep into more what you learned today. So this was, you can take as a, how he said, tip of the iceberg, and then we will slowly start exploring the iceberg. Hopefully he is also having a workshop and a village in besides Agra as well. So those who are interested, I am pretty sure you're going to learn a lot at besides Agra. So don't forget to have your early bird tickets. We are just 2 days left for early bird sale, and early bird passes link is in your chats, which is pinned, so you can grab your early bird passes, and we'll love to see you there at besides Agra. Okay then, everyone, I'm ending the meeting, and thank you so much to everyone for joining and staying till the end.
Thanks, everyone.
Okay.
Thanks, yeah. Bye.
Thank you, sir.
Bye.
Hi, bro.